Hey everyone, welcome to Computer Science Tech Paper Summary. I'm Alex.
I'm Jordan. And today, look, we're not just diving into a paper. We're basically stepping into a time machine.
Ooh, okay. Where are we going?
Imagine, just for a second, you're back in the late 1980s. You're at CERN.
Okay, CERN. European Organization for Nuclear Research. Big science. Particle accelerators.
Exactly. One of the most intellectually vibrant, but also incredibly complex places on the planet. You've got thousands of brilliant minds, scientists, engineers, programmers.
All working on huge stuff, right? Like building the next generation of particle accelerators. Pushing boundaries.
Totally. And information, as you can probably guess, is just flying around.
Like subatomic particles.
Yeah, pretty much. Ideas sparking in hallways, code being written, complex hardware design.
And the people themselves, the ones with the knowledge.
They're coming and going, often just on 2-year contracts.
Okay, so picture this massive brain power, this constant activity, but also this constant churn. How on earth do you keep track of anything?
Right. What if that vital knowledge, the stuff built up over years of hard work, just vanishes when someone packs their bags?
How do you stop yesterday's breakthrough from becoming tomorrow's forgotten footnote just because the person who knew it moved on?
That is the exact, really pressing challenge that Tim Berners-Lee was staring down in March 1989.
Ah, the man himself.
Yes. And it's what led him to write this, well, seminal document, Information Management, a proposal. He updated it a bit later, May 1990.
Okay, so an internal proposal for CERN sounds maybe a bit dry, specific.
You'd think so, looking at the title.
Yeah.
But for us, looking back now, it's basically a foundational text. It's this quiet giant that sketched out the blueprint for everything.
And when you say blueprint, you really mean it, don't you? This wasn't just some clever fix for CERN's filing system.
No, not at all. This was the genesis, the very beginning of something so revolutionary, so profoundly impactful that it underpinned pretty much every single digital thing we do today.
We're talking about the World Wide Web.
We are talking about the World Wide Web, the actual fabric of it, the global interconnected system you're probably using right this second to listen to us.
Wow, okay, so this 35-year-old document isn't just a history lesson.
Not even close. It's this incredibly sharp, prescient analysis of a problem, a huge problem that, honestly, most of the world didn't even know it was about to have.
And it offered a solution.
A remarkably elegant one, scalable. It's just this powerful example of how clear thinking about one specific urgent need can lead to something universal, something that changes everything.
Okay, let's dive in then. Let's unpack this. We need to understand that world. CERN in the late 80s, this wonderfully chaotic place.
Yeah, CERN back then was amazing. Berners-Lee himself called it a wonderful organization.
So picture it. Thousands of people, many of them very creative, he says, all pulling towards these massive goals.
And it wasn't like a rigid corporate hierarchy, not top-down. Information didn't just flow neatly down prescribed channel.
It was more organic.
Yeah.
Messy.
Exactly. Think of it less like a ladder and more like like a web, a bustling, interconnected ecosystem. Formal meetings, sure, but also informal chats, corridor gossip.
He actually used that phrase, didn't he? Multiply connected web of informal communication.
He did, which is just chills, right? Thinking about what came next.
Seriously, it paints such a vivid picture. Gossip solving problems faster than meetings, people just sharing software, grabbing coffee, and having breakthroughs.
A very fluid, dynamic system, almost alive, and incredibly successful despite, the inevitable cross wires or duplicated work you get in that kind of environment.
But even with all that success, Berners-Lee saw a hidden cost, right? Something undermining it all.
Yes, he pinpointed this critical problem, information loss, relentless information loss. And it wasn't just annoying, it was a fundamental drain. It was slowing things down.
So if all this great work is happening, what was actually causing this information black hole, this leakage?
Well, a huge factor was the high turnover, people staying, often, just for 2 years.
Right, 2 years. Think about that.
You bring in these brilliant people, they spend ages getting up to speed, learning incredibly complex systems, becoming experts.
And then, poof, they're gone, just as they hit their stride.
Exactly. And Berners-Lee points this out. New people needed a fair amount of their time and that of others just to get oriented.
So it's not just training new hires, it's this constant, inefficient rediscovery of knowledge, relearning lessons already learned over and over.
That's a big part of it. But it's also about knowledge just disappearing completely. permanently.
Like the actual technical details of past projects? Gone.
Precisely. He says critical details were sometimes lost forever.
Wow.
Or, maybe even worse, the information was written down somewhere, but finding it required, and this is his phrase, a detective investigation in an emergency.
Okay, that sounds stressful. Like having a library with no catalog. The book you need might be there, but good luck finding it when the reactor's melting down, metaphorically speaking.
Right. The information existed, but it cannot be found when you desperately need it. Imagine a critical system failure, and the fix is buried on some old tape or in the head of someone who left 3 years ago.
That's terrifying. Urgent problems needing frantic searches for stuff that should be accessible, wasting incredible amounts of time and money.
Absolutely. It was holding back the science.
This whole situation makes me think about trying to document something really complex and dynamic. Like the urge is always to write the big book, right?
Yeah, the definitive manual.
We'll just write it all down, perfectly organized, one massive document. Sounds logical,
Uh-huh. Until you hit the reality of a place like CERN.
which is not static at all.
Not even slightly. He says it's constantly changing as new ideas are produced, as new technology becomes available, and in order to get around unforeseen technical problems.
So that big book, it's obsolete before the ink dries.
Pretty much. That's the big book fallacy he identified. For a one-off static project, maybe, but for CERN, forget it.
The structure would need constant fixing. You'd spend more time updating the index than doing the actual research.
Totally unsustainable. Impractical.
So what kinds of basic, everyday questions were people struggling to answer? The kind of stuff you need to know to get work done.
He gives some great, very concrete examples. Things like, where is this module used?
Okay, yeah. Crucial for any software engineer. Dependencies.
Or, who wrote this code? Where does he work?
Basic collaboration stuff. Need to ask a question, fix a bug.
What documents exist about that concept? So you're not reinventing the wheel?
Right. Building on past work.
Which systems depend on this device? Vital for maintenance, upgrades.
Absolutely. Can't swap out a part if you don't know what relies on it.
And even what documents refer to this one? Which hints at that need for cross-referencing, for context.
These aren't obscure questions. They're fundamental for any big project, really.
Totally. And without quick answers, things grind to a halt. Mistakes happen. Money gets wasted.
And this is where his, almost prophetic vision comes in, isn't it? He didn't just see this as CERN's problem.
No, he explicitly wrote, and this is just an amazing line, CERN is a model in miniature of the rest of the world in a few years' time.
Wow.
CERN meets now some problems which the rest of the world will have to face soon.
So he saw it coming. This wasn't just about physics labs. It was about businesses, governments, everyone. The information explosion.
He absolutely saw it. He saw the future, and it was tangled, fragmented, and desperately needed connecting.
It's incredible how this very specific, high-tech problem became the seed for something so universal.
He recognized the pattern. Information sprawl, information loss. He felt the pain point before most people even had enough digital information to feel it.
Okay, so the big book is out. Relying on gossip isn't scalable. What about the tech solutions they did have back then? Why weren't they working? You mentioned these rigid tree structures.
Yeah, this is a really key part of his argument. Traditional systems, things like hierarchical file systems or help systems, they looked organized on the surface.
Like a neat family tree. Everything in its place.
Right. Think of CERNDoc, their document system, or VMSLP, or the Unix file system. Their big advantage. Every item, every node, had a unique name based on its position in the tree. Sounds good. But, and this is the fatal flaw he points out, they do not allow the system to model the real world.
Because the real world isn't a neat tree.
Exactly. Especially not a research environment. It's got cross-connections, sideways links, things belonging in multiple places at once.
It's like that VMSL example he used. That really stuck with me. You drill down deep into one specific branch.
Yeah, like help compiler source format pragmas defaults. You finally get to the leaf node expecting your answer.
And it tells you to go look somewhere else completely different, like help compiler command options defaults pragmas.
Right. You have to mentally back all the way out, leave that branch, and then navigate down a totally separate one.
It proves his point perfectly. The information was not naturally organized into a tree. The connection was obvious, but the system couldn't handle it.
It forced you into this rigid, unnatural path, broke your concentration, wasted time, like having to walk around the block to get next door.
And it wasn't just help systems. He mentioned UCP News too, right? Those early online forums.
Things like alt.hypertext. Discussions naturally wander, don't they? They evolve.
Sure, a chat about hypertext might drift into censorship or something.
Exactly. And logically, that new topic maybe belongs in alt.individualism or a sock group. But the system, the tree structure, had no easy way to link across those branches.
You were stuck in your silo, even if the conversation moved on.
Totally. He quotes this guy, Scott Duncan, in alt.hypertext, actually asking, where should we take this discussion? This doesn't feel like the right place anymore.
Wow, so users were literally asking how to break out of the rigid structure?
Yeah, it perfectly shows the frustration. The system couldn't keep up with how people actually think and talk. It was a straitjacket.
Okay, so trees are too rigid. What about keywords? That seems more flexible. Just tag everything. Search for the tag.
Keywords were common, yeah. But Berners-Lee hit on this fundamental human problem. Two people never chose the same keywords.
Ah, the classic synonym problem, semantics.
Right, which meant keywords really only worked well for the people who already knew the system, who knew the agreed-upon terms, the insiders.
So if you were new or just didn't guess the magic word, you were stuck.
Pretty much. It created another kind of silo, accessible only to the initiated few.
It's still a problem today, isn't it? Even with fancy search engines. I call it Project X, you call it the Zurich Initiative, Bob calls it that thing we did last summer. How do you find that thing?
Exactly. Some systems tried to fix it, like VaxNotes had registered keywords, a controlled vocabulary,
Better, baby.
a step, sure, but it still didn't capture the relationships between concepts or documents. It was just a flat list of tags. Still not enough to model the real complexity at CERN. Like having a dictionary but no thesaurus, no map of how ideas connect.
Okay, so the old ways weren't cutting it. Big book. Nope. Rigid trees. Nope. Keywords. Flawed. He needed something radically different, something that embraced the chaos, the connections.
Yes. And this is where the brilliance really shines, where the web idea starts to emerge.
So what was the vision, this pool of information he talked about?
He wanted a system that allowed a pool of information to develop, which could grow and evolve with the organization.
Grow and evolve. Organic, not imposed from above.
Exactly. And the key principle, the absolute core idea was the method of storage must not place its own restraints on the information.
Direct shot at those rigid trees and keyword lists.
Totally. Let the information shape the system, not the other way around. Fluidity, adaptability.
And he had that great analogy, right? The circles and arrows.
Yes, so simple, so powerful. He pointed out that when we try to explain complex things, family trees, flowcharts, org charts, we naturally draw circles for things and arrows for the connections between them.
He basically said, let's do that, but digitally. A system where circles and arrows can stand for anything.
It's such an intuitive model. The circles are what he called nodes. They could be anything: small notes, articles, comments, data points.
Representing people, projects, ideas, documents, hardware.
All of the above, anything. And the arrows connecting them are the links.
And crucially, these links weren't just generic connections, they had meaning.
Yes, this is so important. An arrow from A to B wasn't just connected to. It could mean A depends on B.
Okay, vital for software or hardware.
Or A is part of B, component relationship.
Makes sense.
A made B, authorship. A refers to B, cross-reference. A uses B, dependency again. A is an example of B, illustrating a concept.
So you get this really rich description of the relationships, much smarter than just an index card.
Absolutely. And this whole nodes and links thing, while maybe new in computing for this application, it mirrored how people already drew diagrams.
Right, you mentioned family trees.
People nodes as parent of links.
Data flow diagrams.
Software modules passes data to links.
Dependency charts modules depends on links. Pit charts for project management. Tasks must be done before links.
Org charts, people, reports to links. He saw this fundamental pattern in how humans visualize complex relationships that don't fit neatly into hierarchies.
And he thought, let's make that digital and universal. Bring that intuitive diagramming power to the computer. Let information connect freely.
That's the core insight.
Hmm.
And the beauty is how it solves that keyword problem we talked about.
How so?
In this linked system, keywords themselves become nodes. Nodes representing concepts.
Ah, okay, so not just tags on a document.
Right. Documents now link to these concept nodes, which allows for powerful indirect connections.
So if document X links to the physics node and document Y also links to the physics node?
They become related, even if they don't mention each other directly or use the exact same keywords.
And a keyword search changes completely.
It's not just looking for a word, it's looking for nodes which are close to a concept node. You can explore outwards, follow connections, see related ideas.
Like navigating a mind map, not just an index, discovering things serendipitously.
Much more fluid, much more intuitive, powerful.
And this wasn't just theory for him, was it? He'd actually built something like this before.
He had. Way back in 1980, he wrote a program called Inquire.
Inquire.
Yeah, to manage software info, link snippets of information. He even compared it to the old text adventure games. Adventure.
Huh. Clicking through rooms, but with information.
Kind of. Following links from one sheet of info to another, it was his personal prototype.
So he was scratching his own itch years earlier, using it himself.
Absolutely. For his own notes on people, projects, software. He mentioned it was a bit like Apple's HyperCard, which came later.
Right, HyperCard was huge on Macs, personal hypertext.
But the key difference he highlighted. Inquire ran on a multi-user system. Shared data.
So even back in 1980, he was thinking collaborative, shared information, not just personal notes. That multi-user aspect was baked in early.
It seems fundamental to his thinking. Figure 2 in the paper actually shows an Inquire screen. It's for the RPC project.
What does it look like?
Basically a list of related things, documents, concepts. But the power is that each link has a type, like includes and maybe comments.
So not just RPC relates to user manual, but RPC includes user manual context.
Exactly, like includes the VaxNose conference, vxcern.rpc, or includes RPC user manual. It's an interconnected map of documentation relationships defined. Much clearer.
And he actually missed this program when he came back to CERN later.
He did. He even wrote a version for VMS, the system they use heavily there, just for himself. Found it personally very useful.
For tracking projects, people, software.
Yeah. And even though he didn't polish it for others, he noticed a few people have successfully used it to browse through the projects and find out all sorts of things of their own accord.
Which just shows the power of the idea itself, right? Even a rough version was discoverable, useful.
The linked information had intrinsic value, which leads right into the idea of hotspots.
Clickable links.
The direct precursor. Visual cues, maybe an icon, maybe highlighted text that were sensitive, touch them with the mouse.
Or maybe even an early touch screen.
Possibly.
Yeah.
And it would bring up the relevant information or expand the text.
He described it so clearly, didn't he? Something like, imagine the references in this document linked to the network address.
So that while reading this document, you could skip to them with a click of the mouse. Boom! That's the hyperlink, the engine of the web page.
And he gave credit to Ted Nelson for hypertext, right? Coined back in the 50s.
He did. Defined it as human-readable information linked together in an unconstrained way.
And he distinguished that from hypermedia.
Yeah, hypermedia would add graphics, sound, video. He saw that potential, but his proposal focused on hypertext first, solving the core information problem with text.
Because practically for CERN, it had to work, right? It needed to meet some tough requirements.
Absolutely critical. These clear, practical requirements basically shape the DNA of the web.
Requirement number 1.
Remote access.
Okay.
Across networks. Essential for CERN, being so distributed. People in different buildings, different countries.
Got to be able to reach the information. Non-negotiable. Okay, number 2.
Heterogeneity. This was huge. CERN was a mix of everything. IBM mainframes, Macs, VAX VMS, Unix.
All sorts of different computers, different operating systems.
The system had to let all of them access the same data. Couldn't be tied to one vendor. Platform agnostic. Radical for the time.
Which leads to number 3, non-centralization.
Yes, also radical. He knew systems start small, isolated, then grow and merge. So the new system had to let existing independent systems link together without central control.
So not rip and replace everything with our one giant database, more like let's connect what's already there. Decentralized.
Completely countercultural for the mainframe era, but vital.
And this connects to what feels like the absolute killer app, the stroke of genius, accessing existing data.
The linchpin. He knew this thing had to be useful immediately. Critical usefulness early on.
Couldn't just wait years for people to manually add new stuff into it.
Exactly. It had to tap into the treasure trove, the mess, the vast amounts of data already scattered across CERN's existing systems. Instant value.
Okay, but how? How do you magically make all these different old systems look like hypertext without rewriting everything?
The gateway program. Brilliant concept.
Gateway. Right, explain that.
Okay, so instead of migrating data, you have this special server, a hypertext server or gateway. Its job is to look at an existing database, say an old personnel directory or a document archive, and dynamically present it as if it were hypertext.
So it translates on the fly, creates a hypertext view.
Exactly. Doesn't create a new database. It just acts as a viewer, a lens, mapping the old structure onto the new linked model in real time. Figure 3 in the paper shows this beautifully. Browser talks to gateway, gateway talks to old database, presents it as linked info.
That is clever. It bypasses the impossible migration task. It lets the web become this universal overlay.
And it meant they could connect anything. Old text files, complex databases, anything with some structure could be viewed through this hypertext lens without central coordination.
That's the key to scaling it, isn't it? Okay,
Yeah.
so what kinds of existing systems did he actually envision linking up?
Oh, he had a whole list. It shows how broad his thinking was.
Well, like what? Give us some examples.
Okay, UUCP News, that early Unix forum system. The gateway could link related posts, even across different groups.
Makes sense. Vax notes, too.
Yep, Digital's conferencing system, same idea. Then CERN the official document system.
So documents, authors, keywords, all become interconnected nodes.
Exactly. Explore documentation trails, not just look up numbers.
What else? It wasn't just documents, was it?
No way. File systems. Any file could become a node, linkable.
Wow. Even the phone book.
Even the telephone book.
Yeah.
View as hypertext. Link people to groups, buildings, floors. Click a name, see their projects, their team. Turns a static list into a live org map.
That's cool. What about technical stuff?
The Unix manual. Huge flat text. But it already had those see also bits.
Implicit links.
The gateway makes them explicit, clickable. Turns the manual into an interactive resource.
And commercial databases, like proper databases.
You have a generic tool to give any DBMS a hypertext view. This whole connect everything approach was crucial for getting widespread adoption fast.
He even talked about enhancing old systems, right? Not just viewing them.
Yeah, like putting special codes, a standard format for a reference, inside existing news articles or reports.
So you type a little code in your text file.
And the gateway sees it and automatically turns it into a live, clickable link when someone views it.
Whoa. So you're actively weaving the web into the old content. True integration.
It showed such a deep understanding of augmenting existing workflows, not just replacing them. And beyond access, he also saw the need for personal touches, private links.
Like bookmarks.
Exactly. Your own private links, connecting public info in ways meaningful to you, maybe adding your own notes, annotations,
Yeah.
foreshadowing bookmarks, highlights, comments. We use this stuff constantly now.
Recognizing the individual within the shared space. Smart. And then there's the really mind-bending part for me, data analysis.
The intriguing possibility. This is where it gets really powerful. If you have a big database with typed links that mean something,
Like depends on or reports to.
yeah, then you can do some degree of automatic analysis.
What kind of analysis?
Finding anomalies, like undocumented software, code modules not linked to any project, or maybe divisions which contain no people, organizational errors.
Okay. Interesting, like sanity checks.
It could generate mailing lists automatically based on who's linked to what project or group.
Yeah.
But the really big idea was analyzing the topology of an organization.
The structure.
Yeah, making sense of the tangle. He used that great analogy. A 3D model with spheres for people, strings for connections.
Right, seeing who collaborates with whom.
The system could map these connections, reveal the tightly knit groups, find the weak areas of communication.
Yeah.
Understand how the organization actually works, not just how the org chart says it works.
That's basically modern organizational network analysis, using data to see the real social and technical fabric. Amazing.
And it wasn't just static data either. He talked about live links.
Live links, meaning...
Following a link might not just get you a document. It might retrieve info that's changing all the time. Real-time data.
Okay, like sensor readings or status updates?
Could be. And even more revolutionary, a link could fire up a special application.
Whoa, like click a link in a manual.
And it launches a diagnostic program for the specific device you're reading about.
Yeah.
Gives you live data, runs a test.
That's blurring the lines between information and action. Documentation becomes interactive control, incredible foresight.
Truly. But it's also interesting what he explicitly called non-requirement.
That wasn't important.
Things like strong copyright enforcement, complex data security, accounting for usage. He said these were of secondary importance at CERN, where information exchange is still more important than secrecy.
That feels like a different world, doesn't it? Compared to today's internet, where security, privacy, monetization are huge issues.
A very different philosophy. For him, at that time, in that context, open, rapid information flow for science was the absolute top priority, frictionless sharing.
Okay, so the vision was huge, but he wasn't naive. He knew there were challenges, right? He acknowledged existing research and problems.
Definitely. He was well aware of the academic work, especially around users getting lost in hyperspace.
That feeling when you've clicked 10 links deep and have no idea where you are?
Exactly. Even back then, researchers in HCI knew this was a potential usability nightmare for complex link systems. Maybe less critical with CERN's basic text terminals then. But he knew disorientation was a real factor to consider.
What else? What other hurdles did he see?
The siloed world of databases. Most systems back then were self-contained. Ted Nelson's dream of a wide docuverse with links spanning different databases on different machines, that was mostly just a dream.
Lack of interoperability, a big hurdle for a universal system.
Huge. And standardization efforts at the time, they were mostly focused on things like formats for optical disks, publishing static info, not on networking standards for live, distributed linking across different systems.
So he was trying to fill a gap nobody else was really focused on, connecting live, dynamic, distributed information.
Precisely. And many of the early hypertext systems that did exist were often proprietary,
Yeah.
tied to one computer brand or OS. No portability, hard to link them together.
So the landscape was fragmented, full of limitations.
Yeah.
But he still saw momentum, right? Things were happening outside CERN that gave him hope.
Yeah, he saw the growing research buzz, those hypertext conferences, 87, 88, standardization workshops by NIST. The field was definitely heating up.
But the real push came from the military.
Huh, yeah. Funny how that happens sometimes. The U.S. Department of Defense's CALS initiative, Computer-Aided Acquisition and Logistics Support.
CALS. What was that?
It basically mandated that future defense contractors had to deliver all their documentation manuals, parts lists in hypermedia format.
Whoa. So if you want to sell jets or ships to the DoD, you need hypertext.
Massive incentive. Suddenly, hypertext wasn't just academic, it was a strategic requirement for huge contracts. Plus, support was growing from publishers, librarians, people whose job is information.
Okay, so the tide was turning, and internally, for his own system design, he made that crucial architectural decision: client server.
Yes, separating the storage software from the display software. The server holds the data, the client browser displays it, connected by a well-defined interface.
Key for network access, key for heterogeneity, different clients on different machines accessing different servers.
Absolutely. And defining that interface, that common language, was critical. He called it an important phase.
Because once you define the interface,
Then browser development and server development can happen independently, in parallel. New browsers can be written, new data sources can be plugged in, old systems can be adapted. It future-proofs the whole thing, decouples content from presentation. Brilliant.
and all this leads back to his main goal.
A universal linked information system, where generality and portability matter more than fancy graphics or extra features. Keep it simple, make it work everywhere.
Get it adopted. Reach that critical threshold.
Exactly. Make it useful enough that people start using it, adding info, making it more useful, which attracts more people and info. A virtuous cycle.
And the gateway idea was the accelerator for that cycle.
Right. Seed the system by linking in all that existing data. Instant value, rapid growth.
So how did he propose actually doing this at CERN? What was the practical plan?
A clear two-phase project. Phase 1. Get 2 people, spend 6-12 months surveying what's out there, look for existing tools, browsers, servers that are portable, extensible, future-proof, maybe combine components. Don't necessarily reinvent the wheel.
Smart. Leverage existing work. Phase 2.
Programming. Build the actual system at CERN, and crucially integrate it with existing data right away to get that immediate usefulness.
Get people hooked early. And he had that little aside, that techie wink.
Oh yeah, the parenthetical comment. And yes, this would provide an excellent project with which to try our new object-oriented programming techniques.
Huh. Such a perfect snapshot of the era. Thinking about OPOP while laying the groundwork for the entire web. Amazing.
It really is. So wrapping it up, this proposal was just this masterful diagnosis of a huge, looming problem information chaos and an incredibly elegant, practical solution.
This flexible, interconnected web, linking new stuff, but crucially, linking all the old stuff too, allowing growth, evolution, even analysis.
Exactly, solving CERN's problem, but designing it in a way that could and did solve the world's problem.
So as we rack up, just think about that ripple effect. 1989, a specific proposal for a specific place. But look around now, clicking links, collaborating online, searching your phone, navigating company data.
It all traces back to these core ideas: nodes, meaningful links, decentralization, gateways.
Makes you wonder, What are the big information problems we're facing today? What needs that kind of radical rethinking, that kind of creative connection? What's your information management problem that needs a new diagram of circles and arrows?
Something to definitely think about.